PowerShell functions conceptually are just like functions from any language that you may have encountered previously. A function is simply a named series of operations, and if you have its name, you can call it over and over again, so functions are reusable. When you create a function and give it a name, you declare the function, and as part of the declaration, you can specify inputs to the function that are called parameters. Functions can then take those parameters, do whatever the function needs to do, and then return some additional data. Optionally, doesn't have to, but usually does. PowerShell functions can participate in the object pipeline. So there's a particular syntax that you can use to make a function work with the pipe object and work the way you would expect it to. And the end result is that a function can act just like a commandlet. Let's jump over to PowerShell ICE and write a very simple hello world function. In PowerShell ICE, I've gone ahead and opened up the script pane, and I've got a new script called untitled1.ps1. And what I'm going to do is write a very simple hello world function. Now, PowerShell function starts with a declaration that says that what follows is a function, and that declaration is the function keyword, followed by the actual name of the function. All right, and so I'm going to name this function write hello world, keeping in mind that in PowerShell the convention is verb noun. All right, so what this does is write, and what it writes is hello world. So the next thing I need is the parameter list. This one isn't going to have any parameters, so I just use two params to indicate that there's an empty parameter list, and then the function body is surrounded by curly braces. And what I want this function to do is just take the host and write out hello world. All right, now if I run this right now, you can see all I get is what is in the script in the shell. So to use this, I need to save it. Or rather, click the save button would help. And we'll call this hello. I'm just going to overwrite one that I created previously. And now if we run it, you can see it just says cscripts hello.ps1. But by running that, it has created the function within the context of my current operation, or my current session. Right? So I could say, start typing, and you can see IntelliSense picks up on the fact that there is a function there called write hello world. And so if we run this, then we get our output hello world. All right, simple enough. Function keyword declares the function, followed by the name, followed by the argument list, followed by an implementation which is contained inside of curly braces. If you're going to be sharing your functions with anybody else, I think it's really important that you follow the verb-noun naming convention for your functions. And the convention is to use Pascal case. So, in other words, big G on the get, and then capital letters on the words, so get child item. The reason this is important is because there are a set of common verbs that Microsoft publishes. And so the reason this is a best practice is if you give the function to somebody else and you've used the common verbs, then it's going to be really easy for them to kind of jump in and take advantage of that function. So I always recommend that you follow Microsoft's common verbs convention for consistency. So get should always get something, set should always change a value, add should add something to some collection, delete, or rather remove should remove something from some collection. Now functions take parameters. And there are a couple of ways that you can add parameters to the function. The first way is as an argument list. So the declaration, and inside the params, just a set of variables separated by commas. But you can also use the param keyword, and if you use the param keyword, this has to be the first line of the function. And so that just says param x comma y as the first line of the hypothetical add numbers function. And then finally, if your function may take an unknown set of arguments, you can use an array, which is used with the named variable args. All right, so let's jump back over to PowerShell and actually write some functions with parameters. So the example I used on that last slide was a function called addNumbers. So let's go ahead and write addNumbers in a couple of different ways so we can experiment with functions and passing parameters. Right, so we'll start off by doing the most common form of this, which is to just have an argument list. And so we'll say this is going to take an x, and it's going to take a y. And then what it's going to do with these things is just add them together and write the output to the host. All right, so what I want to do is do the addition first and then write that output to the host. So I wrap it inside some parens, and I'm going to say x plus y. And now I need to save this library. So I had one here I wrote previously called functions. I'll just use it again. And when I run this, it adds the addNumbers function into my current console session. And if we say 4 and 7, the answer is 11. All right, so another way that I could get the parameters is to use the param keyword and just specify them inside the function body. So let's take this version and use it as the basis of the next one. This time, we're going to take this and get rid of the argument list inside of the function declaration, and we'll simply say param x and y. All right, we'll call this one addNumbers2 and save our work and run the script. And now if we addNumbers2, the answer is still 11. Right, but what if we wanted to write a function that took an unspecified number of numbers and just added those all together? Well, that's where the args variable comes into play. Now this time, I'm going to leave off the argument list completely from the function declaration. I could have left it off here as well. I'll take that off just to prove that to you so that it'll work. And what I'm going to do is just loop over whatever got passed in. And so I'm going to use for each. And what I'll do is I'll say for each one of the n, which is the number, in args. You can see IntelliSense knows all about args. And what I'm going to do is I'm going to take a result and add to it whatever n happens to be. And then when I'm done doing the loop, we'll say return result. All right. IntelliSense was telling me there that it didn't know what result was, and that's because I left the $sign off of it. All right, so let's run the script so these all get loaded. And first off, let's make sure addNumbers2 still works. All right, 4 plus 6 is 10. And now let's try addNumbers3. So we'll take 4, 6, and 5 and run this, and the answer is 15. Now notice here that I did not use writeHost, I used return. Let's talk about that. I think it's fair to say that compared to most other languages, the way return values work in PowerShell is a little strange. It's a little weird. Because the way it works is whatever a function adds to the object pipeline is what the return value is. So the return keyword, all it does is exit the current scope. And if the return keyword is followed by something, then it adds that thing to the pipeline and then exits the current scope. And so as a result of this, it's really easy to return more than what you intend to return. Right? So let me show you what I'm talking about. This will make a lot more sense. So this is a really easy bug to create, so pay close attention. Okay, so we're going to use the functions that we wrote previously to explore how return values and the object pipeline actually work together. Right, we're going to start by considering the first function, add numbers, which currently has a body that calls writeHost commandlet with x plus y. And what writeHost does is it takes whatever you pass to it and writes it out to the output window, or whatever the host happens to be, because you can use .NET applications to host PowerShell if you want. Right? And so all this is doing is taking the result of this operation and writing it right here. Okay, and we can see that easily if I take add numbers and say we'll take add numbers and we'll call add numbers for the first argument, and then add numbers for the second argument. And what we ought to get is this should, well, let me actually show you what happens when we run this, and then I'll talk about why. All right, so if I run this, we get 2, then 4, then blank. Because this does not actually return anything. It just writes 2. And this doesn't actually return anything. It just writes 4. And so when add numbers runs the third time, the inputs to it are blank and blank. And so the result of that is an empty line. All right, so if we wanted to actually return this expression instead of using writeHost, we can write to the output by using the writeOutput commandlet. And let's save this and run that line of code again, and you can see that now we get the expected result, which is 6. Now, in fact, writeOutput itself is optional, because whenever we have an expression that isn't assigned to something or passed around, then it just gets written to the object pipeline. So if I took writeOutput and just got rid of it, and we save this, and then I run that command again, you can see that it still works. Because this is in fact the same thing as just saying, right? So this expression 2 plus 4 evaluates to 6, which is what gets written out. And this here is kind of the key to the whole potential for making a mistake with return values. So let's come down here to add numbers 3 and say that I was just confused for a second. I was thinking that maybe I was writing in some other language, and so I decided to be a good programmer and initialize result. All right, so I just have results sitting there. And I'll go ahead and save this. And let's say we said add numbers 3, and we passed in 1, 2, 3, 4. Well, we get an answer 10. So it looks like everything is okay, but actually I've created a dangerous little bug for myself. Because if we take that expression and test to see what its data type is with getType, I can see that what I have is an object array. And so if we were to do something like this, instead of getting the answer 20, we get 10 and 10, because these aren't numbers, they're arrays. And what the array has in it is an empty slot from this line of code, and then here when we called return, attempting to explicitly return the variable result, that works. There's just something else with it. So I could delete this code, but instead I'm going to show you a handy commandlet that you can use to suppress the result of an operation being written inadvertently to the object pipeline. I'm going to pipe result to the out null commandlet. And basically what that says is just eat this, evaluate it, but don't pass it on. Right, so now if we get the type, we can see that this is actually now an int 32. And if we try to add those things together, we get the expected result, which is 20. Now, This example that I've given you here may seem a little strange because you're probably thinking, well, I wouldn't do this, and so that bug that Doug's talking about just isn't going to happen to me. But any function that you might be calling could be writing something to the object pipeline. And so say you called the function and you wanted to do some processing, but you weren't interested in catching its return value. Well, that return value, because you didn't catch it, is going to go into the object pipeline. And so the safe thing to do is to call that function and then pipe its output into out null so that whatever operation it does completes, but you don't get your object pipeline polluted. There's a lot more to the object pipeline than accidentally adding things that you don't want to be in there. And when you're working with the pipeline, a lot of times you'll see the expression $_. And what this is one of those implicit or automatically created variables, and what it represents is the current object in the pipeline. Now, one of the syntax improvements they made in PowerShell 3 is that they made this symbol optional in a lot of contexts. Not always optional, but often optional. The thing is, it's not optional in PowerShell 2. So if there's any chance that the thing you're writing may need to work with PowerShell 2.0 or earlier, and you have chosen to leave this off in one of the optional scenarios, you should probably reconsider that decision because your script won't work in an earlier version of PowerShell. All right, so let's do a simple little demonstration of this to show you what I mean, and then we'll talk about working with the object pipeline in a little bit more depth. All right, so what I'm going to do is I'm going to make a little hash table called grades. And so this is a collection of key value pairs separated by semicolons. And so we'll say that the first one's going to be Fred, and his grade is 90. And the second one is going to be Bob, and Bob is not as smart as Fred, so his grade is going to be 40. And we'll run this, and if we check grades, we should see that we have this nice little table laid out for us. So everything's looking good. All right, so what we'll do is explore the $_ by using where object, or the where filter. And so we'll take grades and we'll pipe it, or rather I need to get the enumerator, easy to forget to do. And I need to pipe this into where. And this is one of those optional cases, so I could say underscore dot. And we're going to say the name is equal to Bob. Right, if I run this, ooh, I did something wrong. It's because equal is not how you do comparisons. It's actually done with EQ. So to indicate equality, let's try that again. All right, and there we go. We got Bob with the value of 40. If we run this without the $_, I get that the term name is not recognized as the name of a commandlet function, script file, etc. So this is an example of where $_ is not optional. And so I think that even though it's often optional, unless you're really sure, it's just easier to use it than to not use it. The $_ variable, which I'm just going to call the current item from here on in, is something that you need when you're writing functions that are going to read the pipeline. And any function can actually read the pipeline. Pipeline processing has 3 stages. The first stage is begin. It runs once and it runs first. And then the process block is going to run for each item in the pipeline. And then the end block is going to run exactly once and run last. There are actually 2 implicit variables or automatic variables that you get when you're doing pipeline operations. The first one is the current item, of course, and then there's another one which is input, and that represents all of the items. It's important to note that input is not populated until after begin has executed. All right, so let's write a function that can process some pipeline input. All right, so what I'm going to do is I'm going to take a function which I intend to receive the pipeline from getChildItem. In other words, the list of items that are in the current folder, and write them out in a particular way. Right? So I'm going to call this function write file names. Now, I'd say this one's a little bit ambiguous. I might actually need to call this format something to really obey the Microsoft standard. But this name will work well enough for the purposes of this demonstration. And so I'm going to write some output when the process begins, then I'm going to write out each item, and then I'm going to write out some output when the process ends. All right, so what we're going to do to begin with, whoops, is just write some output to the host. We'll say the files are. And I'm also going to initialize a count at this point in time. So we're going to keep track of how many files there actually were that we processed. So we'll say count is equal to 0. Now that's going to run, and then for every one of the items, the process block is going to run. And what we'll do here is we'll write host whatever the current item's name happens to be, and then we'll just increment that counter by 1. Right? And then finally, the end block is going to run. And what we'll do here is we'll just write host that we found count files. All right, let's go ahead and run that. Actually, I'm going to save it, and we'll call this pipeline. And we'll run this, and now we'll say get child item, and we'll pipe that into write file names. All right, let's give this a try and see what happens. All right, so the output looks wrong, and the reason is I've got a syntax error right here. So while I was talking, I said plus equals 1, but I left the plus out. And well, here you have a good example of me writing out more to the pipeline than I meant to, because each one of these would be in the output of this command. All right, so let's try this again. We'll save it and run it. And now we see that the files are, and these are, some of these are directories, others are files, and there were 12 of them. Right? So it's as simple as that. Begin runs once, process runs for each item. Use $_ the current item to access the one that you're processing right then, and then end runs one time and last. One of the most important things to worry about when you're writing functions in a scripting language is controlling the scope of your variables. A variable's scope is its visibility across blocks of code. And by default, variables are local in the functions in which they're declared, but they're going to be visible to the container of the current function, its children, and any functions it invokes. And this behavior is very dangerous for complex scripts. In order for you to really understand what I'm talking about, it's much easier to take a look at some sample code. So let's jump over to our PowerShell machine and let me demonstrate exactly what I'm talking about. Okay, so we need some variables to actually examine. So I'm going to start off by making a variable called x, and we'll give x the value of 20. And then I'm going to make a function, and we'll call this function writeX. And inside of writeX, we will make a variable named y and set it equal to x. And then we'll write out to the host the value of x. Right, let's take this function, we'll make one below it called rateY. And this one we'll write, or attempt to write, y out to the host window. And then at the bottom of our script, we'll call rateX, and then we'll call rateY. All right, so I'm going to save this. We'll call this scopes, and we'll just run this function. Right, and what we got in terms of output was 20 from this line of code, and then blank from this line of code. So what this demonstrates is that at the moment, this variable that we created inside of x is not visible inside of y. All right, so let's change this example up a little bit. First off, I'm going to add right up to the top of this function a couple of remove variables. Because it is important to remember when you're debugging that the variables that you create part of the console session, the command shell that we happen to be in. So we're going to remove variable x, and we'll also remove variable y. Just so you know, there's nothing up my sleeve when I do this. All right, so I'm going to take away rateY down here. Whoopsie. Let's try that again. I'm going to take away rateY from down here, and I'm just going to come up here under rateX and add it in. Okay, so let's run this and see what happens. And I got an error off of the remove variable. Couldn't find one called y. But you can see that the second write, this one, now can see y. So by virtue of being called from the rateX function, rateY is able to see this variable which was created inside the rateX function. All right. What we'll do is we'll just do clear for these two guys. I just want to make sure I have this right before I move on, so I'm going to run this one more time. All right, that's good enough. I can live with that. The main thing is I want to be sure if I accidentally do get that into memory that it's not going to cause a problem for us. But x exists because it was declared right here. Y at the moment is only visible inside of rateX, and now it's visible inside of rateY because x calls y. So what this tells us is that whenever we call a function from another function, that whatever it has inside of it, caller has inside of it, becomes visible to the callee by default. Now it's possible to influence this behavior by doing something called dot sourcing. Now you've probably seen me dot source a script before, but you can also dot source a function. Right? So what I'm going to do, I'm just going to get rid of these clear variables here because I'm about to create a y right at the top of this function anyway. And we're going to say y is equal to ABCD. All right, and we're going to leave rateX alone. We're going to leave rateY alone, but we're going to come down here to the bottom and we're going to call rateY right here. And I'm going to put a dot right in front of rateX. And what's going to happen as a result of this is that rateX is going to be treated as if its commands were part of the outer function that we have here, right? So by dot sourcing it, when I assign y equal to x inside of rateX, instead of creating a new variable called y that's existing for this function, I'm actually going to be saying I want to use this y right here. So let's see what happens when we run this. Right, and so you can see that this dot sourcing proves what I just said, because what we see is now 20 for the first rate host, 20 for the second rate host, because when this got run as dot source, this overwrote this. And then when we call write y again, of course y is now local and is written out as 20. So I just go back to something more similar to the first example and run this. You can see that by removing that dot, I get ABCD instead of 20. I showed you that because it illustrates some of the weirdness of scoping rules inside of PowerShell, but I think really this is bad form and you should not do it. Now the final thing I want to show you is that in PowerShell we can nest functions just like we can inside of JavaScript. All right, so I'm going to change this around. I'm going to take write y and I'm just going to copy it, or rather cut it, and we'll move it right here inside of write x. And right here I'll change this one to say write host. For the existing y. Now the reason I need to change this is because by putting write y inside of write x, write y is now no longer visible outside of the write x function, so there's no way for me to call it. Well, let's save this and run our script one more time. And you can see this time I got 2020, so it wrote host 20, which is what x is equal to. And we overwrote y with x, so inside of write y, this copy of y is equal to 20, but this version of y is local to write x. And so when we write host y down here at the bottom, we get this copy of y, which is ABCD. Now, if you think that these examples that I just gave you were a little bit hard to understand, imagine if you are debugging some script you wrote and some script that somebody else wrote, and you have a bug that's been introduced because of some scoping behavior. Clearly, it is not safe to rely upon the built-in default behavior of variable scope. All right, so if we can't rely on the default behavior, then we need to explicitly control our scope. Now, there are the level of scopes that we actually witnessed just a second ago were global variables, local variables. Actually, we didn't witness global, but we did witness local because that's the default in functions. You can create private variables, which you have not seen yet, and then you can scope things to a script, which is the default in scripts. And when I say default in functions or default in scripts, I mean this is what you get if you do not explicitly identify the scope of a variable. So these four things, global, local, private, and script, are called script modifiers, and what you do is you apply a script modifier to explicitly control the scope of a variable when you create it. The scoping rules work on the scope modifiers work on variables, they work on functions, they work on aliases. So any place that you might need to control the visibility of a thing and prevent collisions with some other script or even your own script, then controlling the scope explicitly is really a good idea. Let me show you how we can use this to really control what we get instead of relying on the default behaviors. All right, let's play around with some of these scope modifiers. The first thing that I'm going to do is I'm going to come up here to the write x function, and where we see y, I'm going to say that y is going to be private. All right, as simple as that. That is the scope modifier, private. All right, so we're going to write host x, and we'll change this write y to call just write host y. And inside of write y, I'm going to use another scope modifier. I'm going to create a global, and this is going to be called z, and z is going to be equal to bad style. Generally speaking, global variables are to be avoided. All right, so we'll write host y, and we'll write host z. And now we need to call write y because it's still nested inside of write x. And then down here at the bottom, we'll write x, write host y, and write host z. All right. So let's save this. And this time I'm going to set some breakpoints to make this a little easier to follow. So I'm just going to right click here and toggle a breakpoint on the first line that executes that we're interested in stopping on, and I'll go ahead and run this. All right, so here we are on line 18, and let's start stepping. All right, so we'll just step over this, and right there a whole bunch of things happened. We see 20, 20, ABCD, and bad style. So when we wrote X here, we got 20, and when we wrote Y here, we got 20, not ABCD, because what this one is writing is not what the IntelliSense is saying, which is this one, but rather this private variable right here. Right, then we got into write Y, and we created Z, which is called bad style. And so the next thing we write out is Y, and this time it writes ABCD, because even though write Y was called by write X, and even though it's nested inside of write X, when we gave the private modifier to Y, we gave write X its own private Y that is not shared with anybody else. And then we wrote Z, which of course is equal to bad style. But then now down here, when we go to write host Y, it's going to say ABCD again. Right? ABCD. And of course Z is global, and so it's equal to bad style. What you need to take away from this, though, is that private needs to be the most common access modifier that you use. I think the best practice is if you have a variable that's inside of a function that should only be used by that function, you should always decorate it with private.